Good day, learners. I am Ms. Loreline Agres from Padre Burgos Elementary School, and I will be your teacher for today's lesson. For today's lesson, we are going to solve routine problems involving area of composite figures formed by any two or more of the following shapes, such as triangle, square, circle, rectangle, and semicircle. So, routine problems are problems which we can easily identify the solution to the problem with just looking at the word clue. So please remember that a composite figure can be made up of some or all of the following shapes such as triangle, square, rectangle, and semicircle. So now, let's have problem number 1. On a blueprint, a rectangular room 24 feet by 20 feet has a semicircular seating area attached with a diameter of 24 feet. What is the total area of the room and the seating area? To solve for the problem mentioned, we are going to use four-step process. First, we have to understand the problem. Second, we need to plan. Third, we solve, and fourth, we checked. Let's analyze problem number 1. So first, we're going to understand the problem. Now, let's answer. What is asked? Very good. This problem asks for the total area of the room and the sitting room. Good, let's continue analyzing problem number 1. After answering what is asked, now we are going to answer what are given. What do you think are the given measurements here in this problem? Very good. In this problem, it says here that we had a 24 feet by 20 feet, which is the size of the rectangular room, and the 24 feet, which is the diameter of a semicircular seating area. Very good. The second process is to plan. So what operations are we going to use? Correct. We're going to use multiplication, division, and addition. So what will be the number sentence? You're right. So we will have length times the width plus pi r squared divided by 2 is equal to n. So this illustrates that the area of the rectangular room will be added to the area of the semicircular seating area to get the total area of the room and the seating area. So the third process is to solve. First, we solve for the area of a rectangle. So the area of a rectangle, we are going to use area is equal to the length times the width. Can you tell me what is the length and the width of the rectangle? Correct. So the length is 24 feet and the width is 20 feet. Now we substitute the formula with the given measurement. So we have area is equal to 24 feet times 20 feet. Now can you tell me the area of the rectangle? You're right. So the area of the rectangle is 480 square feet. Very good. So now after we solve for the area of the rectangular room, we're going to solve for the area of the semicircle. So what formula are we going to use? Very good. We're going to use the formula area is equal to pi times r squared divided by 2. So we know that pi is equivalent to 3.14. And to get the radius, we are going to divide the diameter, which is 24 feet, by 2. So 24 feet divided by 2, we will have the radius of 12 feet. So now we substitute the formula with the given measurements. So area is equal to 3.14 times 12 feet squared divided by 2. Therefore, we will have area is equal to 3.14 times 144 feet squared divided by 2. If we multiply 3.14 by 144 feet, we will have 452.16 feet divided by 2. So if we divide 452.16 divided by 2, we will have very good. We will have the area of 226.08 feet squared. Very good. That's nice. So now we have the area of the rectangular room, which is 480 square feet, and the area of the semicircular seating area, which is 226.08 square feet. So now we are going to solve for the area of the composite figure. To get this area, we are just going to add the area of the rectangle and add the area of the semicircle. So now we will have the area is equal to 480 square feet plus 226.08 square feet. So if we add this one, what will we get? Very good. We are going to get 706.08 square feet. Now, so the answer to the questions is that the total area of the room and the seating area is 706.08 square feet. That's very good. So to check, we're just going to minus the area of the rectangle to the area of the composite figure. If we get the area of the semicircle, then our answer is correct. So we have 706.08 square feet minus 480 square feet, which is the area of the rectangle. What do you think is the answer? Very good. We have 226.08 square feet, which means the area of the semicircle. Therefore, our answer is correct. Now we have here problem number 2. Let's read. Susan is laying a carpet on the floor of a rectangular room. The length of the floor is 16 meters and the width is 10 meters. The border around the carpet is 1 meter wide. Find the area of the floor not covered by the carpet. So now let's analyze problem number 2. So like we did earlier, first we're going to understand the problem. What is being asked? The answer is very good. We are going to find the area of the floor which is not covered by the carpet. So after we know what is asked, so now we are going to know what are the given. So based on this problem, what do you think are the given? Very good. First, we are going to get the 16 meters, which is the length of the floor. Second, we have 10 meter, which is the width of the floor. And the third one is the 1 meter, which is the border around the carpet. Very good. So after understanding the problem, we're now going to plan. So what are the operations to be used? Very good. To get the answer for this problem, we are going to use multiplication and subtraction. So next, what could be the number sentence? Okay, so to get the area of the floor not covered by the carpet, we have the area is equal to the area of the floor, which is length times width, minus the area of the carpet, which is length times width. Very good. So now look at the figure. We have here the length, which is 16 meters, the width, which is 10 meters, and the border around the carpet is 1 meter wide. So now we solve. First, we solve for the area of the floor, which is the length times the width. So we will have area is equal to the length times the width. So what are we going to do next? Very good. We are going to substitute the formula with the given measurements. So we will have area is equal to 16 meters times 10 meters. If we multiply those, what will be the answer? You're right. We are going to have area is equal to 160 square meters. Very good. So now we are going to solve for the length and the width of the carpet. First, we are going to get the length. So we have 16 meter, which is the length of the floor, minus the 1 meter border from the left side, minus the 1 meter border from the right side. So we will have, very good, we will have 14 meters. So now we're going to get the width of the carpet. So we have the width of the floor, which is 10 meters, minus the 1 meter border from the left side and the 1 meter border again from the other side. So we will have 8 meters squared. Very good. So now we are going to solve for the area of the carpet. Since we have the length of the carpet, which is 14 meters, and the width of the carpet, which is 8 meters. So we get area is equal to length times width. Then we substitute. So we have area is equal to 14 meters times 8 meters. So what will be the answer? Okay, good job. So we will have 112 square meters. So now we are going to solve for the area of the floor not covered by the carpet. So we have the area of the floor is equal to 160 square meters, and we also get the area of the carpet, which is 112 square meters. So we have 160 square meters minus 112 square meters. What will be the answer? You're right. We have 48 square meters. So the answer for the question asked is that the area of the floor not covered by the carpet is 48 square meters. So now, after solving, we are now going to check. So to check, we are going to add the area of the floor not covered by the carpet and the area covered by the carpet. So if we get the total floor area, then we got the right answer. Now, let's add the area of the floor, which is 48 square meters plus the area of the carpet, which is 112 square meters. So if we add this one, what will we get? So we will get 160 square meters, which is the area of the floor. So did we get the correct answer? Yes, because the area of the floor is 160 square meters. Very good. So now let's move on to problem number 3. So here, Melvin asked his brother to help him find the area of a composite figure in square meters in this figure. So now, let's analyze problem number 3. So given this problem in this figure, we are now going to use the same 4 processes. First, understand the problem. In understanding the problem, we are going to ask questions. So in this first questions, what is asked in this problem? Correct. So this problem asks for the area of composite figure in square meters. So look at the figure. What are the given in this figure? You're right. So we have 10 meters, 3 meters, 7 meters, 5 meters, 3 meters, and 8 meters as the measurements of the sides of these composite figures. Very good. After understanding the problem, the second process is to plan. And here we're going to answer the questions. First, what operations are we going to use? What do you think is the answer? Correct. We're going to use multiplication and addition. The second question is, what would be the number sentence? You're right. So the number sentence is, first we're going to find the area of the first rectangle, which is length times the width, and add it to the area of the second rectangle, which is length times the width. Then we will get the total area of this composite figure. Okay, good job. So the third process is to solve. First, we are going to solve for the area of the first rectangle. Then we have area is equal to length times the width. Then we substitute the formula with the given measurement. So we have area is equal to 10 meters times 3 meters. So what will be the area of the first rectangle? Correct. The area of the first rectangle is 30 square meters. Good job. So now, let's move on and find the area of the second rectangle. So we also have area is equal to the length times the width. Then we substitute the formula with the given measurement. So we have area is equal to 3 meters times 5 meters. So what will be the area of the second rectangle? Correct. So the area is 15 square meters. So now let's solve for the total area of this composite figure. Like we said earlier, we are going to get the total area if we add the area of the first rectangle to the area of the second rectangle. So we have area is equal to 30 square meters plus 15 square meters. So if we add those, what will be the answer? You're right. Area is equal to 45 square meters. Good job. So now, we will get to answer the questions that the area of the composite figure in square meter is 45. You've done a good job in solving this problem. So in this lesson, please remember that routine problems are problems which we can easily identify the solution to the problem with just looking at the word clue. And composite figures can be made up of some or all of the following shapes, such as triangle, square, rectangle, circle, and semicircle. And that ends our lesson for today. Did you understand it very well? If not, you may go back to the lesson presented in your modules. If today's lesson is very clear to you, Congratulations, you may now answer the exercises in your modules. Don't forget to enjoy learning and good luck.